Okay, on note 6.5, we're going to be writing the quadratic equation. So it's kind of like the opposite of what we've been doing. We've been given the equation and then we were graphing it. So here we're going to be given some information and we're going to have to come up with that equation by using the three forms that we've already talked about: vertex form, root form, and standard form. All right, so let's look at number 1. So it says, write the equation of the quadratic function with roots at 4 and -1 with f of 0 equaling 8. So that f of 0 equals 8. That means when x is 0, your y is 8. So that ordered pair would be 0, 8. So we're given roots and we're given a point that our line goes through. So what we need to do is we need to plug it into root form since we're given the roots. And we are missing our a. So we're going to have to find a, which is the coefficient in front. So first I'm going to write down my root form. I'm going to say my R1 is 4, my R2 is -1. And then I'm going to plug in 0 for x and 8 for y. So we're going to plug everything in. The only thing we won't know is our a. So y is 8. We don't know a. X is 0 minus R1, which is 4. And then x is 0 minus R2, which is a -1, so that would make it +1 on the inside there. And then we're going to work this out. So we have 8 equals a. 0 minus 4 is a -4. And then 0 plus 1 is 1. So notice we're doing a times a -4 times 1. I want you to rewrite this as -4a because we're just multiplying all those together, but we have a variable there, so put that -4 in front. So now we're solving for a. So now all I need to do is divide both sides by -4, and we have a equals -2. Once you find a, then what you're going to do is plug it back into your root form without that x and y point of 0, 8, but also plug your roots in. So we're going to have y equals a, which is a -2, and then we have x minus R1, which is 4, and then x minus R2, which is a -1, so that would make it +1. So you're using that point x and y to find a. Once you find a, you're going to plug it back into your root form. Do not plug anything in for the x and y because we want an equation there or a function that we can graph. So there's our root form. So if you're given the roots, plug into root form. If you're given the vertex, plug into vertex form. All right, let's look at number 2. So it says write the equation of the quadratic function with a double root at 4, which means R1 and R2 will equal 4. And then we're given a point, f of -1 equals 5, which means the point would be -1, 5. So since we're given roots again, we're going to plug into root form. We're going to plug everything in and find a because we're not going to know what a is. So plugging in, I know y is 5 equals a. X is -1 minus R1, which is 4. And then x is -1 minus R2, which is also 4. So we're plugging in. We get 5 equals a. -1 minus 4 is a -5. Same thing on the next one. And we're multiplying all those together. A times a -5 times a -5, which would give you 25a. Go ahead and write that number in front because you're multiplying it all together. Divide by 25. Make sure you're dividing by 25 and not 5 here. The answer is not 5. A would equal 1/5. So again, once we know a, we're going to plug it back into our root form without the x and y. So y equals a, which is 1/5. And then x minus R1, which is 4. And then then x minus R2, which is also 4. So you could write it like that, but I'll also accept since it's the same, x minus 4 squared. So either one, I'll accept both. All right, let's take a look at number 3. So this time we're given a graph, and we're going to have to find some things from the graph. So it says, write the equation of the quadratic pictured below in root form. If we are wanting to put it in root form, that means we need to find the roots, which are your x-intercepts. So I'm given a point again at 0, -12. R1 would be 1, and then R2 would be 3. All right, so we're going to plug into root form. So y is -12. We're looking at this point here. Equals a, and then x is 0 minus R1, which is 1, and then x is 0 minus R2, which is 3. So we should get -12 equals a times a -1 times a -3. So we're going to have -12 equals 3a. And then solving for a, we get a equals -4. So once we find a again, we're going to plug it back in without plugging in for x and y, because we need that in our function. So y equals a, which is a -4, times x minus R1, which was 1, R2, which was 3. And it doesn't really matter which one's R1 and R2, so you could have wrote -4 times x minus 3 times x minus 1. All right, let's take a look at the next one. So on 4, we're wanting to write the equation of the quadratic function with a vertex of 3, 1, and then f of -4 equals a -13, which means -4, -13. When we're given the vertex, remember the vertex, we're going to use vertex form. Remember the vertex is h and k on your vertex form. And then we're going to plug in our point, -4, -13. Just like the front, we're going to be missing our a, so we're going to need to find the a. So plug in, y is -13. We don't know a. X is -4 minus our h, which is 3, squared, don't forget that, and then plus our k, which is a 1. So we get -13 equals a. -4 minus 3, which is a -7. We need to square that and then add 1. All right, a common mistake when you're plugging in to find a on vertex form is doing 7 squared plus 1 and then putting an a with that. That a only belongs to the 7 squared. So 7 squared is 49, that should be 49a. So that plus 1 you need to bring down. So that's a common mistake, so be careful on that part of it. Do not do 49 plus 1, which is 50, and then put the a. So we're getting a by itself, so subtract 1. We get -14 equals 49a, and then divide by 49. So a, we're going to reduce that, would be -2/7. So same thing as the front. Once we find a, we're going to plug it back into, on this one, vertex form. So y equals -2/7 x minus h, which is 3, squared, plus k, so plus 1. All right, so if we're given the roots, make sure that you plug into root form. It'll be easier. If you're given the vertex, plug into vertex form. That will be easier. Let's look at 5. Write the equation of the quadratic function with a vertex. So that's h and k, which is -1, -6. And then f of 5, which is 6. So that should be a 5, 6 for the ordered pair. So I'm plugging into vertex form. So we can find a. So our y is 6. X is 5 minus our h. Common mistake is putting -1, but it should be +1 because you're subtracting a -1. Don't leave off the squared. Plus k, and k is a -6. Make sure again that you work this out before you subtract 6. So that's going to be 36a. Okay, so then we will add 6. And that would be 12 equals 36a divided by 36. Reduce it, and that should be 1/3. So once we find the a, again, we're going to plug that back in without plugging in the x and y. So we're going to have y equals a, which is 1/3, times x minus h, which is a -1, so that's +1 squared, plus k, so -6. All right, let's look at number 6. We have a graph this time. Make sure on the graphs that you read what it wants you to find or what form it wants you to put it in, so that way you know what you need to find on the graph. So if it says root form, find the roots. If it says vertex form, find the vertex. So notice this one says vertex form, so we want to find the vertex. Notice it already gave us that vertex, so -2, -2, so that's your h and k, and then our point is 0, 1. So we're plugging into vertex form, looking for our a. So y is 1, x is 0, minus h, which is a -2, so that makes it +2 squared, and then -2. Again, do not try and subtract the 2 with that. So that'll be 2 squared, which is 4a. So add 2, and you get 3 equals 4a. So a would equal 3/4. So plugging it in, you get y equals 3/4. X minus h, h is -2, so +2 squared, and then -2. Make sure you check also on, once you find your a, check the direction. If it's a positive, remember it should be opening up, and notice that it is opening up. So that's a way that you can check and make sure that you found the correct a. The back problem will be a separate video, so make sure you watch that one.